Hello everybody, my name is Hunter Ream, and today I'm going to be talking to you about the breadth first search algorithm. First, let's start by going through an example. Consider this graph. Ultimately, what we want to do is start at the first vertex, which I highlighted in blue, and search through the whole graph and find the 9th vertex, which I highlighted in green. For the sake of this video, every single time that I highlight a vertex blue in the graph, we'll say that that vertex has been visited. Since the first vertex is already blue, let's go ahead and call it visited. Once something is visited, let's put it in the queue. Here's where we start to apply the actual algorithm. First, we're going to look at the very first vertex and consider its neighbors. I highlighted the neighbors in blue in the graph, which we're only looking at the vertices 4 and 2, but since those are now colored blue, we're going to put those into our queue. To keep the algorithm going, we're now going to move up a level. We're going to look at the next vertex, which is the 4th vertex. And now we're going to consider its neighbors. If we look at the graph, we see that, well, the neighbors of 4 are 1, 5, and 7, but the only 2 neighbors that have not been visited yet are just the vertices 5 and 7. Those are the 2 vertices that we're going to put on the queue now. Now we look at the vertex 2, which is the next vertex going up the queue. Its neighbors are vertices 1, 5, and 3, but we're only going to consider the vertices that have not been visited yet, and that's actually only the vertex 3. Let's go ahead and put that on the queue now. So we're just going to keep doing this algorithm until we find either the goal vertex or until we've looked at every single vertex in the graph. You'll see that we'll actually end up finding our vertex number 9. It is the last vertex we look at, but nevertheless, we found it. Heuristically, how this algorithm is working is we start at one vertex, which in our case is vertex number 1, and we consider that as the first level. Then we look at all of the unvisited neighbors of that level, which are simply just the neighbors of 1, namely 2 and 4, and that's going to form our next level. Looking at the neighbors of that level give us the vertices 7, 5, and 3, forming the 3rd level. So the idea is we can sweep through the graph considering levels in this way. Ultimately, you'll visit every node, and thus you will be able to find whichever node you're looking for. This algorithm is actually pretty fast. At worst, you're going to be visiting every vertex about once, and you're also going to be visiting every edge about once. So we say that the complexity of this algorithm is O of n plus m, where n and m are the number of vertices and edges, respectively. If you do need to search through your graph to find some specific vertex, then this would be a good algorithm to use. So that you can use it, let's walk through some pseudocode. So in order to define the breadth first search algorithm on a graph, let's call the graph G, we're first going to start by letting the letter Q be a queue. This letter Q is what's going to represent the box that we had on the right side of the screen previously. Next, we're going to choose a root vertex, and then we're just going to put that root vertex right into our queue. So to start the actual algorithm itself, we say while Q is not empty, first we're going to take something off of the queue. Now we know that this thing is going to be a vertex, and if it is the vertex we're looking for, in other words, if it's the goal, then we're simply just going to return U, or we're going to say, hey, you found it. But otherwise, you're going to look at all of the vertices, W, which are adjacent to U in G. And if W has not been visited yet, then we're going to label W as visited and put it right onto the queue. Each iteration of this while loop is going to be forming the levels that I was talking about previously. If we make it through the entirety of this while loop, meaning that the queue actually emptied itself, then we can safely say that the vertex we were looking for was not actually in our graph, so we can just return something like goal not found. This is the end of the pseudocode. If you want to see a worked out example of this in Python, then you can click on the link in the description. I hope this video was helpful. If you like this video, or want to learn more graph theory or just learn about other cool math topics, I encourage you to subscribe. Regardless, I hope to see you soon. Thanks for watching.